Hey everybody, it's Mr. Bliss. In this video, we're going to talk about electron configuration. Last time, we talked a little bit about ions, which are charged particles with either more or fewer electrons than the number of protons. We also talked about isotopes that have varying numbers of neutrons, which affect the atom's mass. We looked at the periodic table and trends in the periodic table, and we also looked at models of the atom. If you remember, we looked at a timeline of how our understanding of the atom changed over time. Our current best understanding of the atom is known as the quantum model. But the quantum model is actually pretty difficult to understand when we're dealing with elementary chemistry. So what we're going to do is, in this video, we're going to focus on Bohr's planetary model of the atom. And in Bohr's planetary model of the atom, which is very similar to this picture right here, we're going to think about the electron as a particle that kind of circles the nucleus in like a planet. Well, that's why it's called a planetary model. Planets orbiting a sun. The most interesting thing, or the most apparent thing about this model, is that electrons exist in what are called electron shells. And that just means that you have your nucleus here, and then around the nucleus you have these shells in which electrons exist. The way to think about these shells is that electrons will fill in from the inside out, and they build outward to get bigger, which makes sense because the atom itself gets bigger. So here are some ways to understand and think about these electron shells. The first shell holds 2 electrons, and we're going to draw it like this because electrons have a negative charge, so we're going to say 2 electrons. The second shell holds 8 electrons, and we are going to say, for the sake of this video, that the third shell also holds 8 electrons. Now, some of you who are watching this who have some deeper understanding of chemistry are going to say, wait, Mr. Bliss, doesn't the third shell hold 18? Well, yes, kind of. We're going to deal with that later on, but it's a little bit tricky. So for right now, what we're going to do, just to understand the concept a little bit, is we're going to say that this third shell holds 8 electrons. That will change. So just put a little asterisk on that in your minds. All right. So another way to think about these shells is that they actually relate to the period on the periodic table. And I will show you what I mean by that. So I'm going to scroll down. Here's our periodic table. What I just said is that the first electron shell can hold 2 electrons. So as an example, what we're going to do is we are going to look at the electron configuration of helium. We're going to start off with helium. Now, just to keep things simple, what I'm going to do is I'm going to write He like this. This is going to be our nucleus. You can imagine that the nucleus actually has 2 protons and 2 neutrons, but to keep it simple, I'm just going to keep it like this. We are going to draw in the electrons here, and so I'm going to draw this first shell, just like this. We know that helium has an atomic number of 2, so it has 2 protons, and that a neutral atom of helium will also have 2 electrons. So how are those going to fill in? The first one is going to go right here. I'm going to put in a little negative sign to remind us that it's negative. And the second one is going to go right here. Now the reason why it goes on the opposite side is that both of these are negatively charged. And we know that like charges repel each other. So when we think about the way that these electrons fill in, it's almost like strangers on a bus. As they come onto the bus, they're all going to get their own seats until there's no more empty seats. Then they'll start to double up. So here, this is the way it'll fill in. However, if we go on to lithium below it, it's going to look a little bit different. So here's lithium. Its nucleus is going to have 3 protons and probably 3 neutrons as well, depending on which isotope we're looking at. But the way that we fill in the electrons is a little bit different than helium. We're not going to put 3 electrons in this first shell. Now the reason why we're not going to put 3 electrons in this first shell is that we said that the first shell can only hold 2. So instead we're forced to go to the second shell. And that makes sense to us because if we look at the periodic table here, what we can see is that the first period of the periodic table is hydrogen and helium. Then we're forced to go to the second period, the second row. This is going to be the second shell. So here's our second shell, and we're going to have 1 electron filled in like this. Now, I want to focus a little bit on the fact that this is our outermost shell in lithium. It has 1 electron. And we're going to give you a term here that's really important. It's called valence electrons. What's a valence electron? A valence electron is the electrons in the outermost electron shell of an atom. Well, why is that important? If you think about the way that things interact in the world as they bump into each other, what's interacting aren't these inner electrons like this one and this one. Those are kind of shielded. The only ones that are really going to affect the way that things interact in the real world are these outer electrons, like that one right there. So valence electrons are very important. And what we're going to see here is that the valence electrons, the number of valence electrons that an element has, is actually related not to the period, but to the group. So remember, these are our groups here. I'm just highlighting them like this. This is the whole reason for the organization of this table. So what I'm going to do here is I'm going to use a different color. I'll use purple. And I'm just going to label the group numbers. So remember, this is group 1. These are alkali metals. Then we have group 2, our alkaline earth metals or rare earth metals. Then we're going to actually skip for a second. We're going to skip our transition metals because it gets a little bit confusing. And for the sake of this video, let's keep it simple. This group over here is going to be group 3, 4, 5, 6, 7, and 8. And this is what is going to define the number of valence electrons that an atom has. So lithium, being in group 1, right here, has 1 valence electron. Now, just to show you, what we're going to do is I'm going to do the electron configuration of sodium. So here's sodium right here. I'll make that a little bit more visible here. Here's sodium, which is number 11 on the periodic table. Well, which period is it in? Well, this was our first period up here. This is our second period. This is our third period. And that, we said, is going to correspond to the number of shells that we have. So let's do the electron configuration of sodium. We said that the first shell can hold 2 electrons, the second shell can hold 2 electrons, and for the sake of this video, we're going to say the third shell can hold 8 electrons. So let's do sodium here. Here is our nucleus, sodium, and we're going to draw in our, actually let's do this, let's put it a little more centralized so we have room. As we fill in the electrons, remember we need to get to 11 because that's the number of electrons that a stable atom of sodium has. We're going to start with the inner shell, 1, 2. Then we have to go to our next shell here, and we're going to fill it in like seats on the bus. So we have 1 here, 1 here, 1 here, 1 here. Now we have to double up because the seats are full. So we have 4 electrons in our valence shell right now, 5, 6, 7, 8. Now it's full, so we need to go to our third shell. We need to get to 11, remember, so right now we're at 8. Then we have to go to 9, sorry, 8, 9, sorry about that. We had 8 in, we're at 11 now if we count our first shell. So remember, let's count these. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this was our 11th. Well, how many valence electrons do we have? How many electrons do we have in our outermost shell? 1. And that makes sense because if we remember, the valence electrons correspond to the group that we're dealing with here. So remember, we have group 1 here, and group 1 is going to have 1 valence electron. Another thing to realize is that when you have this group, group 8, the number of valence electrons corresponds to how full the shell is. And when you have a full outermost shell, when your valence electrons are full, it's satisfied and it doesn't really want to interact anymore. That's why this group, the noble gases, aren't very reactive. So helium's not very reactive, neon, argon, krypton, they don't really react with other atoms. Okay, so let's take a break there. And what we're going to do next time is we're going to talk a little bit, instead of talking about the Bohr model, we're going to transition and we're going to look at how this relates to the quantum model, how to think about what's actually happening in an atom in a 3D space. It's a little bit more complicated, but if you are ever confused, use this as your model for understanding the way that atoms fill in, or electrons fill in an atom as you move up the periodic table. And we will continue this in the next video.